All right, today I'm going to show you how to do percent composition problems. And percent composition is important in chemistry because if you know the percent by mass of elements in a compound, you can actually determine the formula of that compound. You know, is it H2O or is it H2O3 or something like that. And the way you determine the percent composition of anything is part divided by the total times 100 will equal the percentage. It was like if we said, you know, what's the percentage of girls in a classroom? We would take the total number of people, count the number of girls, and divide. And so we do the same thing in chemistry, but we're doing all these problems by mass. And so I want to show you you'll see kind of three types of problems that you have to deal with. The first problem, again, we're going to do them the same way. Again, it's going to be the mass of the element divided by the mass of the compound times 100. When you see these two problems here, basically what they're doing is they're saying, okay, if you went to the lab and you separated magnesium and oxygen, and you got 8.2 grams of magnesium and 5.4 grams of oxygen, what is the percentage by mass of each one of them? So they're doing this in the lab, and that's the case, all you have to do, so we have the mass of the magnesium, that's the part that's magnesium, the element. We have the mass of oxygen, and then you just add those two masses together, because obviously that would be the total mass of the compound, which is 13.6. So part divided by the total, 8.2 divided by the total mass of those two added together, 60.3%. Notice using sig figs there because of that, and the other 5.4 for oxygen divided by the total is 39.7%. Again, there's a way to check your work in percentages. Remember, the percentages always should add up to 100, very close to it. So you got another one, same thing, get 29 grams of silver that again they took apart in the lab, and they also got 4.3 grams of sulfur from that compound. What is the percent by mass of each one of them? Again, 29 grams of silver divided by the total mass of those two added together is 33.3, 87.1%. Same thing for sulfur. You'll also see a lot of percent, and really, quite honestly, you probably see more of these than those when you're taking a test or something like that. It says calculate the percent of each compound there, and again, it says C3H8. And so if you're going to calculate the percent of each element in that compound, you're going to do that by mass. So what you need to know is what is the molar mass of the compound and what is the mass of each element in that compound. So you've got 3 carbons in there. So the mass, to get the molar mass of that compound, you got to take 12 times 3, and then hydrogen weighs 1, so 1 times 8, and add them together. So the molar mass is 44 grams. That'd be a molar mass of C3H8. So once you get this, so that gives you the total mass. Now again, 36 grams of it was carbon, because 12 times 3, that's the molar mass of carbon times 3, because there's 3 of them, divided by the total mass. And then the mass of hydrogens, there's 8 of them in there, they weigh 1 apiece. So 8 divided by 44, so 82% carbon, 18% hydrogen. If they don't give you the formula for it, you're going to have to put it together right. Again, that should be easier to do this year because you don't have to know all, what hydrogen sulfate is. You can look it up. So sodium's +1 has a +1 charge. Hydrogen sulfate is a polyatomic ion that is HSO4 with a -1 charge. You do have to cross the charges to put it together. You get NaHSO4. And then again, total everything up in there. You get the molar mass of the whole thing. Sodium weighs 23, there's 1 of them. Hydrogen weighs 1, there's 1 of those. Sulfur weighs 32, there's 1 of them. And then oxygen weighs 16, and there's 4 of those. Again, I'm getting all of these numbers from a periodic table, if you're wondering where I'm getting them from. And so then what you do is set up each one of them. So we've got to determine the percentage of each element in that compound. So we're going to do sodium, hydrogen, sulfur, and oxygen. So sodium, again, sodium weighs 23. There's just 1 of them in there. The total mass of all that stuff added together was 120. So 23 divided by 120 is 19%. Hydrogen weighs 1. There's just 1 of them in there. Its molar mass is 1. You get it from the periodic table. 1 divided by 120 is 0.83%. Don't forget, you got to take 1 divided by 120. Again, the mass of the element divided by the mass of the compound times 100, and then you get 0.83%. Sulfur weighed 32. Again, 32 divided by the molar mass, 27%. And oxygen, there's 4 of them in the compound. So you have to account for that. When you say how much does it contribute to the mass, since there's 4 of them in that compound, it wouldn't be 16 here, it would be 16 times 4, 64, divided by 120. And so you get the percentage there. Then the last set of two problems are some of the tougher ones that you'll have to do. But again, I always try to give you to solve these as a pattern. First of all, write down what you have. You've got 23 grams of aluminum oxide. So write that down. Set this part up here as though you're going to dissolve, just like you would up here. Set it up as though you are going to solve for the percent composition of aluminum, because it's asking for grams of aluminum. So set it up as though you're going to determine the fractional abundance or percent composition of aluminum. In other words, set it up just like you would here. So put the mass of aluminum at the top, the mass of the whole compound at the bottom. Again, where do I get these numbers? You look up aluminum weighs 27, but there's 2 of them in that compound. So it would be, for aluminum's mass is 27, be 27 times 2, or 54. Then the compound, again, and you might say, again, how do I know what aluminum oxide is? Well, you got to cross the charges to put it together right. Charge of that's 3 and that's 2. That's how you end up with Al2O3 as far as the molecular formula for that compound. And what I'm trying to do here is find the molar mass for that. So 2 aluminums weigh 54, 3 oxygens, oxygen is 16, 3 of them is a total of 48. You got to add that together. That's how you get the 102 there. So it is this the molar mass of the compound, like we did up here at the bottom, and then the mass, the part that we're looking for. They want grams of aluminum out of this. It's how many grams of aluminum are in that compound? Well, there's 2 atoms, and that each one weighs 27 grams, so 27 times 2 is 54. If you just did that, divided that, that'll give you a fractional abundance of aluminum. If you multiplied it by 100, it would give you a percent of aluminum in that compound. So all you need to do, though, is then take this 25 divided by the mass of aluminum in that compound. Multiplied by the mass of aluminum in that compound divided by the total mass of the compound, and that'll get you the mass of aluminum in 25 grams of that particular compound. As a common sense way of thinking about this, think about some numbers we could do in our head. Let's say we had a compound that was 100 grams. The total mass of the compound was 100 grams, and 50% of it was a particular element. And I said, how many grams of that element would be in that compound? Well, if 100 grams, if the compound weighed 100 grams and it was 50% of that element, it should make sense to you that half of that compound would be that element, or 50 grams. But mathematically, what you would be doing is you would be taking the mass of the compound, 100 grams, and you'd be multiplying it by the fractional abundance of that element, or 0.5. And when you set it up like this, this gives you a fractional abundance. That's what that does. So the next problem, you got 37 grams of C3H8. So we got that. We write that down. They want to know grams of carbon. So grams of carbon goes at the top. Grams of C3H8 goes at the bottom. The way you get this, again, that's the molar mass of this compound. That's what 44 is, because carbon is 12, and there's 3 of them there. So that's a total of 36. Hydrogen weighs 1, and there's 8 of them. And so that weighs 8. Add them together, you get 44. That's how you get the molar mass of C3H8. And the mass of carbon in that compound, remember, there were 3 of them in there. So it's 36 grams. So when you take 36 divided by 44, that gives you the fractional abundance of carbon, and you multiply it by the mass of the compound you actually had, and that'll get you the grams of carbon in that particular compound. So 37 times 36 divided by 44 is 30 grams of carbon in that compound. Because again, remember what I was saying earlier. If it was, let's say it was, 36 divided by 72, it's 50% carbon. All you're doing would be make 37 times 0.5, and half of it would be carbon. We're multiplying it by its fractional abundance with that. Notice in this case, the fraction here is almost 1/2. And so essentially half of the 25 grams of aluminum oxide is aluminum. It's almost 1/2 exactly. So again, the way, again, I would say to solve them, when they give you a mass of a compound and they want to know how many grams of a particular element are in that compound, set them up the same way every time. Write down the mass of the compound, set it up as though you're going to determine the fractional abundance of that compound, multiply, then divide. And that's it. For percent composition problems, you'll have some practice problems to work on. Good luck.